Hey Chem Fam, I'm Chelsea and welcome to the family, a space where we get to the heart of chemistry one level at a time. Let's dive in. So we are going to discuss the valency secret in this video, all right? And we are going to do it in a very fun manner. So we are going to compare our atoms, okay, or group of atoms as influencers. Each one will be like an influencer, all right? So usually what happens, depending upon the level of how big an influencer is, their level of collab for different ads or even various advertisement purposes varies, right? You would have seen that. So like in Instagram, for example, when you do collabs, you can like kind of tag people, right? So let's just hypothetically consider that depend in our case, our influencers can what to say collab with a specific number of other personalities, okay, depending upon their own unique identities. So like maybe the big shots will be able to make more number of collabs, okay, whereas some micro influencers will be making fewer number of collabs. So that depends upon the nature and various aspects, okay, of our entities. So here we are discussing about the atoms or group of atoms. That is how they form collaboration with other atoms. Okay, so it depends upon their capacity to collab. So let's what to say picturize sort of a social media profile of our atoms and try to understand the concept of valency. All right. So we'll start with our basic, that is hydrogen. You see, in case of hydrogen, it is like a micro influencer. Okay, so it can only collab with max one person. Okay, so it has only one slot. It has only one slot to tag with another entity to form the collab. Okay, only one slot. Okay, so just like an influencer, if suppose has only one slot to collab with another influencer, in a similar way, that is what valency is for an atom or an entity. All right. So if I say in terms of collab, if I say hydrogen has only one slot available to form collab with another influencer or another atom, that means that is precisely the valency of that atom. Okay. Now let's see that for oxygen. See, for oxygen, it can form collab with two other atoms. Okay. So therefore, it has two slots. Means its valency is 2. When I say 2, the valency of oxygen is 2. Means it can form collab with two other entities. Okay. Now let's see another example, that of nitrogen. So see, nitrogen has 3 slots available for collab. Means it can form collaboration with 3 other entities. So so its valency is 3. Okay. Now carbon. It's a very important element, carbon. Okay. Uh, in case of carbon, it can form 4 collabs. Okay, therefore it has 4 slots available to hold hands and form collab, or tag 4 people and form do the collab activity. All right. So so in terms of valency, the valency of carbon is 4. Okay. So basically, compared to our real life situation, if suppose an influencer can depend, like how many collabs an influencer can form, okay, in a single post, say, uh, it's just that's what is valency for an atom. Okay, so for hydrogen, hydrogen can form max one collab, whereas oxygen can form 2 collabs, nitrogen can form 3 collabs, and carbon can form 4 collabs. Means collab with 4 people. So that is what is basically valency in terms of chemical, like in chemical world. So the valency of hydrogen is 1, valency of oxygen is 2, valency of nitrogen is 3, and valency of carbon is 4. All right. Now, this is a very interesting case. Okay. There are some entities, as even in the previous videos we have discussed about noble gases. I hope you remember I have mentioned about noble gases like helium, neon, argon, and so on. Okay. So these are entities who live on their own. They are not interested in any collabs. They are happy in themselves. Okay. They are like kind of like private profile accounts. Okay. So they don't form any collab with anyone. There is no slot available for collabs and tags and all that. Tags, for that matter, tags are all disabled. That is their nature. So this is just one example, neon. So they don't form any collaboration with anyone else. Okay. So it means their valency is 0. They don't shake hands with anyone else. Okay. They are happy in themselves. Okay, even you remember when we were discussing how do atoms exist, we studied that atoms exist either in free state or as molecules or as ions. So there were some examples for the ones which exist in free state, and that's exactly what noble gases were, right? So they are happy in their own world. They are not interested in collabing with anyone. They don't have any slots available. For that matter, they have even disabled their tags. Okay, so their valency is 0. Okay, they are like private profile. They are happy in their own world. That's what they are. Okay, so you have to compare them to a private profile with 0 slots available for any sort of folder. Now we will move on to ions. Okay, so we are taking simple ions, that is sodium ion. You remember sodium ion, we represented it as Na positive, and since it's positive, it is what? It is a cation we discussed in ions video. Then chloride ion means it is Cl minus. Cl minus, its negative charge, it is anion. These were the givers, these were the thieves, remember? Yeah. So even in case of ions, there's something known as valency. Okay, so generally in case of ions, you can identify the valency based on their charge. So it is Na1 positive, so it has, based on that, one slot available, means it can form collab with one another entity. For chloride ion, it is 1 minus, so based on their charge, there is one slot available, so it can form a collab with one other entity. So since sodium can form has one slot available for forming the collab, and chlorine has one slot available for collab, they too can shake their hands and form a collab, right? Likewise, there are many other ions with their respective capacity to form collabs, and based on that, which comes from their charge, based on that, they form different ways of collaborations with other available entities in their surroundings. All right. So we can conclude. What can we conclude? We can conclude 2 points. One is that the valency of an element is the combining capacity of that element, isn't it? The combining capacity. Combining capacity means their collab capacity in R terms, right? Or how many depends upon the number of slots available for tags. This is just for you to understand. Okay, so valency of an element is its combining capacity of an element. Some can form collab with two other influencers. So in that case, their valency will be 2. Some can just form 1, so their valency will be 1. Okay, some can form up to 4, so their valency will be 4, and so on. It depends upon the species. All right, and valency of an ion is equals to the units of positive or negative charge present in the ion. Like for sodium ion, it is Na positive. The unit positive, its positive charge is 1 plus, right? So its valency is 1. For Cl minus, it was 1 minus, so its valency is also 1. If suppose it is an ion Mg2 positive, its valency will be 2. If suppose the ion is Al3 positive, its valency will be 3. Okay, you remember polyatomic ions that we discussed? If suppose SO4 2 minus is the ion, then its valency is 2. Okay, so this is what valency is. It is just like how an influencer, based on their levels, form collabs. Okay, their ability to collab. Atoms are just like influencers. They do form collabs with other entities in their environment. Depending upon the nature of the atom, their capacity to collab also varies. Some can form 1 collab, some can form 2 collabs, some can form 3 collabs, and so on. There are some special cases where an entity can form multiple number of collabs. Like at some point, it is forming, say, 4 collabs, or at the next moment, maybe depending upon the environment and situations, they can form a different number of collabs. There are some entities like that as well. So you can refer your books to see the listed, the whole tabular list of different entities and their valencies, and try to understand it based on what I have explained here. All right. Now there is one special case. Okay, so I have here is that special case where I mentioned that a particular entity can show 2 valencies, means 2 ways of collabing. So here we are going to discuss about iron, Fe. So it can be either as Fe2 positive. Oh, there's a mistake. It is 3, or it can be Fe3 positive. Okay, so since Fe2 positive means it can form 2 slots are available for collab, so its valency in this case will be in 2. Whereas for Fe3 plus, there are 3 slots available for collab, so its valency will be equal to 3. Okay, so depending upon its environment and situation, it shows different valencies or different ability to collab. Sometimes it forms 2 collabs, sometimes it forms 3 collabs. Means sometimes it shows valency 2, sometimes it shows valency 3, depending upon the situation. Okay, so and there are further other examples also. So go through the various examples that's available in your textbooks and reference books. And try to relate it to what we just discussed. And here's the viral challenge, collab challenge for you. There's a scenario and followed by a question with few options as answers. Take your time, go through this question and try to answer it, and drop your answer in the comment section. I hope you understood this concept of valency. So see you in the next video.